the angle between two vectors is theta, then the angle between their perpendiculars is also theta. So why I'm saying this point is, because of this point, if you observe which two vectors are perpendicular to each other. Here, looking at this diagram and tell me which two vectors are perpendicular to each other.
Sir, R1 vector and V1 vector are perpendicular, sir.
R1 vector and V1 vector are perpendicular. So if I take this angle, if I take this angle as theta or theta 1, this angle as theta 2, and this angle as theta 3, then the angle between AB and BC is how much? Theta 1. The angle between BC and AC is theta 2. The angle between AC and AB is theta 3. I hope this is clear, right? Now, what will be the corresponding perpendicular sides with respect to the velocity triangle? So, wait. So, this is the radial triangle. This is the velocity triangle. Okay. So, observe, this will be V1 vector. I hope there is no doubt in this. Right. So, if angle between AB and BC is theta, then in this triangle, tell me which angle will be theta.
RQ and
RQ and
PQ.
PQ will be theta. If I take this as theta 1, this will be theta 1. The angle between BC and CA is theta 2. Here it will be
RQ and PR.
they both are the same. Here, if this is theta 3, obviously this will be theta 3. So since the angles in both the triangles are the same, can I say that these two triangles are similar? So when the triangles are going to be similar, can I say triangle A, B, and C is similar to triangle which one?
PQR.
P, Q, and R. Right. Then what can I write? Wait. Is it P, Q, R?
Yes, sir.
No.
In triangle ABC, B is the middle angle, sir. So their theta is 1, sir. So here also
Okay. But it can be in the reverse order, no? Okay. Tell me what is the triangle? It can be in the reverse order also.
RQP.
But that's what I'm saying.
PRQ, sir.
It's PRQ. Wait, RQ is delta V. Yes, it is PRQ. So did you guys understand why it is so? See, I'm trying to do very simple concept. What I'm trying to do is, wherever delta R is there, here delta V should be there for the triangles to be similar. So where is delta R present here? Delta R is across BC. Where is delta V present? It is RQ. So since I've written BC, what should be the corresponding side to BC? It should be RQ. Similarly, what if AB is R1? Here what should be there? PQ should be there. How did things change here? Okay. So, since these two triangles are similar, what can we conclude? Can I say delta R divided by R1 is equal to delta V divided by V1? Can I say it like this?
Yes, sir.
Okay. I can either say this or I can take it as V2 also, not an issue. So if I take it, okay, the triangle that we have, if I take it as PRQ, what is AB? What is AB? AB is R1
R1.
divided by AB divided by what is PR?
V
E2.
V2.
V2 is equal to what is BC?
Delta R.
Delta R
Delta R.
divided by RQ is
Delta V.
So delta V divided by V2 is equal to delta R divided by R1. Can I write it like this? Is it clear to
Yes, sir.
understand? So what I'm trying to say here is V2 is going to be the magnitude of the velocity because I've taken the length of this side, right? Since the object is in what type of since the object motion, can I say V1 is equal to V2? See here, what is this? V1 vector is not equal to V2 vector.
So your voice is breaking, sir.
Voice is breaking, sir.
Okay. From where was it breaking? Uniform circular motion?
Yes, sir, from uniform circular motion. It was breaking.
Okay. I'm saying since the object is in uniform circular motion, the magnitude of velocity at point 1 is equal to the magnitude of velocity at point 2. If I call that as V, okay, I'll call that as V. So what I'm trying to say is I'm writing V1 is equal to V2 is equal to V, but V1 vector is not equal to V2 vector because their directions are different. Their magnitude is the same, but their directions are different. Remember, equal vectors means magnitude and direction should be the same, right? So in the place of V2, what can I write? Can I write it as V? Are you guys able to understand? This is equal to delta R divided by, what is the value of R1? R1 equal to what? It is a radius of the circle, that is R, right? So which implies delta V is equal to V by R into delta R. Accepted? So if I divide with time on both the sides, okay, this delta V by V is what is called as the centripetal acceleration. This is equal to V divided by R into, what is this delta R by delta T? Rate of change of displacement is velocity. So the formula for centripetal acceleration is V square divided by R. This is, as I told you today, this is a very, very important formula for you to remember. So you can make a note of it. See, just go through it once if you have, since I have very less time, you can just go through it. If there is any conceptual doubt, let me know. If not, I will share this document with you. You can copy it. I'll proceed to the next concept.
Sir, can you show the diagram?
Sir, one doubt, sir.
Tell me.
Sir, for naming the triangle C and RQ, no, sir. For naming the triangle, for naming the triangle to be similar, you took, for orientation, you took BC and RQ, no, sir.
Yes.
Corresponding sides, sir.
Your voice is breaking. Your voice is breaking.
No, sir. Sir, now, sir.
Yeah, it is better. Tell me.
Sir, for orientation you took BC and RQ, no sir?
Yes.
Sir, why can't we take AC and AB and PR, sir? AB and PQ to name the triangle, sir.
ABN.
PQ. Then it will
Okay. Let
no, sir.
ABN PQ. Then it will be PQ.
It will come PQ only, no, sir.
Is it coming? Similarly, is we can take PQ. So it will be PQR. So if I take it as PQR, what are we getting? AB is R1, PQ is V1, correct. BC is how much? Delta R. QR is delta R. What is AC? R2. PR is V2. Actually, we can, yeah. See, actually, I'm sorry, guys. Nithun, thank you. See, PQR is a triangle which is similar to ABC. I'm sorry about it. So PQR is a triangle. Did you guys understand how I took it? Wherever I have R1, it should have V1. Wherever I have R2, it should be V2. Wherever I have delta R, it should be delta V. Then what will be the changes that will be occurring here? Instead of V2, you will have V1 and you can leave it as it is. But still you will get the same answer. Answer will not change. Because V1 is equal to V2 is equal to V. Is that clear?
Yes.
That's clear? Okay. See, I want to introduce some more terms that are there. Make a note of it. Basic terminologies used in circular motion. Okay. So I'll create a similarity between linear and circular motion. So in linear motion, if I call something as distance, okay. Similarly, if in linear motion we call something as speed, here we call it as angular speed. Here if we call something as acceleration, here we call it as angular acceleration. Okay. Now listen. So again, I'm taking a circle. So when I take a circle, let's say there is a particle which is revolving from A to B. Okay. Let me say it has covered a distance of S. Okay. It has covered a distance of S. Now with respect to the center, okay, say it covered vector has covered an angle theta. Now tell me one thing. So I am taking the radius of the circular path to be R. If theta is measured in radians, okay, if theta is measured in radians, what is the basic definition of theta? So recollect the definition of radian. Radian is defined as the arc length divided by
P.
Yes.
arc length divided by radius. So theta is equal to, what is the arc length here? Can you guys tell me between A and B?
S.
Yes.
Divided by
S by
radius is
R.
R. So which implies S is equal to R into theta,
Theta.
where S as the distance. So what is the relation between these two? So linear distance is equal to radius times the angular distance. Are you guys able to understand this? So this is the first formula that you're going to learn. S is equal to R into theta, first formula. Okay. So when you have displacement in your hand, velocity, what are we supposed? You need to differentiate. From velocity, you need acceleration. What are you supposed to do? Differentiate. So if you displacement, you get acceleration, right? So instead of displacement, you can replace it with distance. Now, if I differentiate with respect to time on both sides, what do I get? ds by dt is equal to r is a constant because radius of the circle, r into d theta divided by dt. So what do I call this as? Rate of change of distance. What is it? Speed. Guys, are you able to understand or not? I'm not getting response.
Yes, sir.
So V is equal to, so linear speed is equal to R into, what is d theta by dt? This is velocity or angular speed. So what can we conclude? The linear speed is equal to angular speed. It does, okay, again omega is a Greek alphabet. You have seen this kind of a symbol, no? Last year.
Yes, sir.
It is a
Yes,
unit of
sir.
resistance. So this is also called as omega only. Okay, one is in lower case and the second is in upper case. I don't remember which is lower and which is upper. Like how we have small a and capital A, there is also a similar. Okay, so how do you read it? B is equal to R omega. Okay. So V is equal to R omega. If I take this as equation number 2, now if I differentiate the second equation on both the sides, differentiate the second equation on both the sides, what do I get? dV by dt is equal to R into d omega by dt. What is dV by dt? Acceleration. D omega. Okay, so A is equal to R into alpha, but the only difference you need to have in your mind is this acceleration is called as the tangential acceleration. So this is called as tangential acceleration. And what will this is called as angular acceleration. So what is the relation between all these three? S is equal to R theta. Differentiating this, we get V is equal to R omega. Differentiating this, we get tangential acceleration is equal to R into alpha. So these are the related linear and circular quantities.
Sir, can you scroll a little bit up, sir?
Okay. Is this enough?
Yes, sir.
Yeah.
Sir, what is S, sir?
Distance.
R is radius, sir.
R is radius, theta is angular distance. I've written here, no? Radius means R.
Sir, can I go down, sir?
Yeah.
Yes, sir, enough.
Still down, huh?
No, sir, enough, sir. Sir, alpha is also an angular acceleration, sir. Alpha is also theta, sir.
Alpha is angular acceleration.
Okay, sir. It is an angle, sir. Like theta.
Sorry?
No, sir. Is it similar like theta, sir? Alpha, theta, all these things.
No, alpha is also a Greek letter. It's alpha. That's it. See, it is like this. Theta, if you differentiate, DIF means differentiate, you get omega. If you differentiate omega, you get alpha. So that is the order. Is that clear? Now listen. See, we derived the acceleration, we derived the centripetal acceleration, right? So what is the formula for centripetal acceleration that we did? It is v square divided by r. You remember this? So acceleration is v square divided by r. But we know that v is equal to r omega. Accepted? So we know that v is equal to r omega. Substitute it here. Then centripetal acceleration can also be written as r omega the whole square divided by r. Can I write it like this? So this will be r square omega square divided by r. R and r will get cancelled. It will be omega square into r. So what is the formula for centripetal acceleration? You can either r or omega square, both the accelerations for equations for centripetal acceleration.
Sir,
So depending on the question, we will be. Sorry, I didn't get you.
is there any value for omega, sir?
Omega, there is no value. It depends on the question. If they give you that value of omega, then you can solve. Are you done?
Yes, sir.
Yes, sir.
See, what will happen is you have angular displacement is s by r, omega is something. You have all these formulae, right? So depending on the problem only, you will have to solve. For example, so I cannot solve these problems because I have to explain you about frequency also. I think there is a textbook problem. 1 minute. So there is a textbook problem that is given. Motion in a plane. This is there, no? In 4.10, observe. So in 4.10, here also I have to explain you one more concept basically. I thought I'll directly do a problem, but listen. See, you guys asked about omega, right? So what is omega? What did I say omega is? Omega is called as the angular speed. there it also. It is also called as angular frequency. When I saw, as of now, concentrate on the basic. So if I take like this, if I take a circle, now for me to go from point A and come back to the same point A, how much is the radian I'm supposed to cover?
$360.
I told radian.
2 pi.
So for one complete rotation, theta is equal to 2 pi. Can I write it as 2 pi radian? Right. So angular displacement is 2 pi, and what is the name given to the time that is taken to complete one full rotation? So what is the name given to time taken to complete one full rotation? What do we call it as? It is called as time period. You have heard this term, time period?
Yes, sir.
Time period is a capital T. So for covering 2 pi radians, how much time will the particle take? It will take one time period. So omega is equal to 2 pi by T. This is an other formula. Or this can also be written as 2 pi into 1 by T. Can I write it like this? The reciprocal of time period is called as frequency. So we write it as 2 pi into F. You would have learned it in chemistry also. You would have learned the term frequency of an electromagnetic radiation, wavelength, and all those things. No? So there, this concept is also applicable. So omega is equal to 2 pi by capital T, or you can write it as 2 pi into F. So have this point in your mind, and the SI unit, I cannot call it SI unit, I'm just calling the unit of omega is second, because 2 pi is measured in radian, time is measured in second. So unit of omega is going to be equal to radian per second. Is it clear till this step at least? Did you guys understand this basic?
Yes, sir.
So you have to remember this formula. This comes in many places, and 2 pi f is also used in many places. So there is one important chapter in your 11th standard, which is rotation mechanics, that we use this concept a lot. It is a very, very important chapter. Okay. So based on this knowledge, let us do this problem. So where is it? Okay. So there is an insect which is trapped in a circular groove of how much? 12 centimeter, and moves along the groove steadily. Steadily means its velocity is constant. Means it is going in which kind of a circular motion? It is going in uniform circular motion. So the word steadily has that much meaning in it, and completes 7 revolutions in 100 seconds. So in 100 seconds, how much is the total angle it has covered? So in one revolution, it will be able to complete. It is 14 pi radians that it has covered. Okay, so have that in your mind. So 7 revolutions per second is the frequency. So what is frequency? 7 revolutions per 100 seconds. 7 by 100 is the frequency. I hope that point is clear in your mind. Now they're asking, what is the angular speed and the linear speed of the motion? Second, is the acceleration vector a constant vector? If so, what is the magnitude? Okay. So are you guys able to understand what it is? So R is equal to 12 centimeter, F is equal to 7 by 100 revolutions per second. If F is 7 by 100, what is omega? 2 pi into F, right? So 2 pi into 7 divided by 100. That will be 14 pi divided by 100 radian per second. Is that clear? Is this clear, guys?
Yes, sir.
So now they're asking what is the angular speed? Angular speed is 14 pi by 100 radian per second. 14 means 7 pi by 50 radian per second. You can leave it as 7 pi by 50 also. You need not write it as fractional value. It will be pi by 50 radian per second. This is what? This is the angular speed. Now they are asking what is the linear speed. So how to find the linear speed? Linear speed is V is equal to R omega. So V is equal to R is how much? 12 into omega is 7 pi by 50. And the answer will be in terms of centimeter per second because R is given in terms of centimeter.
Sir, omega is angular speed, sir.
Omega is the angular speed, yeah. Is this clear, guys?
Yes,
So omega
sir.
we found, V we found. So what is the second part of the question? Is the acceleration vector a constant? Vector a constant? Now try to understand. I'll show you this diagram. So when the insect is here at point A, what will be the direction of its acceleration? It is going in uniform circular motion. Uniform circular motion, what acceleration is present? What is present and what is not present? Centripetal is present and tangential is 0. Since they use the word steadily, at point A, the acceleration is towards point O like this. When it is at point B, the acceleration is still towards the center. It is C. What is the question? Did you read the question carefully? What are they saying? Acceleration vector. Is acceleration vector a constant? Yes or no?
Yes, sir.
Yes,
It is not constant. Acceleration vector is not constant because the magnitude of acceleration is the same, but at every point, its direction is changing.
Direction difference.
For example, direction. So that is why you need to read it carefully. They asked acceleration vector, but what they asked you about the magnitude of acceleration. Yes, it is a constant. Okay.
Yes, sir.
So
Understood.
acceleration vector is not constant, but its magnitude is a constant. Then they're asking what is the magnitude of it. So the magnitude of the centripetal acceleration is v square divided by r. You have the value of v, you have the value of r, substitute it here, you will get the answer. You can either use v square by r or like how they have used in the textbook, you can use r omega square also. In both the cases, you will get the same answer. Is that clear? So that part alone, I am leaving it to you. Okay. So with this, there is actually one more concept, that is relative velocity in 2 dimension, that I'll try to complete it tomorrow and we'll do a few problems. So for today, what I'll do is I'll share a worksheet, you guys. Okay. The worksheet is based on projectile motion. So try to solve the problems, and if you have any doubt, you ask me tomorrow.
Okay, sir.
Okay. Don't log off. Wait for a minute.
Okay, sir.
Don't log off. Wait. Everybody mute yourself for a minute. Don't unmute yourself. Okay, you can leave. I'll see you tomorrow.
Thank you, sir.
Thank you, sir.